Welcome back to the data visualization part of the course. As with any important topic, let's start with some theory. The process of visualizing data usually involves the following steps. First, you get some data. For simplicity's sake, let's assume the data is already pre-processed and ready to be visualized. Second, you choose the right visualization. Third, you actually visualize the data and then style and label the chart. Each of these steps is challenging on its own. However, in this course, we will not focus on the first one. Instead, we will work with pre-processed data sets ready to be visualized. The third step will be explored in detail in the upcoming sections. It is the meat of the course, as they say. In this lecture, we will focus on the second one, how to choose the right visualization. Choosing the right visualization is like riding a bike. It looks like an insurmountable task in the beginning, but once you get comfortable, it becomes a reflex you cannot forget. I like to say that I don't choose the most appropriate chart anymore. The most appropriate chart chooses me. By the end of this course, you'll be able to say the same, I hope. But before we develop that data viz muscle memory, let's talk theory. We at 365 really like using frameworks. Approaching data visualization is no different, and there is more than one successful framework when it comes to choosing the correct visualization. It all starts with the mother of data science, statistics. In statistical theory, we often talk about types of data and levels of measurement. Quite often, these determine the chart we choose to plot. Okay, let's quickly explore the types of data. There are two types of data: categorical and numerical. Categorical data describes categories or groups. One example would be car brands like Mercedes, BMW, and Audi. They show different categories. Another instance of categorical variables is answers to yes and no questions. For example, if someone asks you, "Do you own a car?" Yes and no would be the two groups of answers that can be obtained. All right. Numerical data, on the other hand, as its name suggests, represents numbers. Without diving deeper into that, examples are the count of objects. For instance, 5 bottles, 3 glasses, 1 table, or 7 cars. Other examples of numerical variables are age, money, height, area, distance, and so on. We can continue like this until tomorrow, but how does this help us to visualize data? Well, knowing whether our data is numerical or categorical could actually guide us towards the appropriate chart. For instance, a bar chart contains several bars or several categories. Therefore, when using a bar chart, you will definitely have some categorical variable which is represented by each bar. Then there will be a numerical measure to show how high these bars will be. How about a pie chart? It's quite similar. There are several categories and some numerical measure to show what portion of the pie is attributed to that category. What about a scatter plot? It seems like both axes show numerical values. Therefore, to have a scatter plot, you need two numerical variables that are plotted against each other. Overall, the statistical theory is extremely useful for data visualization. However, it is also quite lengthy, so we have prepared some readings after this lecture on the topic. What is important for you during this course is to develop your data viz intuition based on these theoretical frameworks. Okay, let's do one more. What about a line chart? Looks like one axis is numerical while the other is a date. A date could be either numerical or categorical depending on your definition. Neither a good option, thus there is a whole field regarding such data called time series analysis. So our initial framework of dividing data into categorical and numerical proves to be insufficient. It is still a great basis, though. As someone who deals with data visualization, I've seen many other frameworks. The best one I've stumbled upon is provided by Data2Viz, and I'd like to quickly introduce you to it. They start with the question, what kind of data do you have? The possibilities are numerical, categorical, numerical and categorical, maps, network, and time series. Then there is a decision tree that guides you to the proper choice. You will quickly notice that this framework is based on the concepts we introduced just a minute ago. Nevertheless, they do so in a smart way, which is not completely restricted to data types. Another useful functionality of Data to Viz is that if you click on visualization, you will see additional information about it. But I believe you can dig into that on your own. So instead, I'd like to turn your attention to one extremely important observation. There is never a single possible chart choice. In reality, there are different ways in which you can visualize the same relationship. Moreover, the same chart could be used for different types of relationships. So how do we choose? Well, in general, you should never choose the most complex of plots. On the contrary, you should keep things simple. Many times I've seen charts that look intimidating or complicated. Upon closer examination, these charts usually turn out to be too confusing and can often be misinterpreted. Remember that you visualize the data for your audience. If you believe they may not understand a given chart, don't use it. The goal of DataViz is to help others understand data, not confuse them even further. With that in mind, if a bar chart can do the job, by all means, use a bar chart. You'd be surprised how often a bar chart does the trick. You may think that is too rudimentary, but a well-executed bar chart is a mark of a DataViz whiz. Great. We can now proceed with our next topic, color theory. Thanks for watching.